Welcome to another video in the Visual COBOL for Eclipse in a Nutshell series. In this video, we'll take a look at how to debug a COBOL application running inside a Linux container which has been deployed beyond the development environment. We'll explore prerequisites and background for this demo, an overview of the process and setup required to debug an application running remotely in a container on Linux. Finally, we'll run through a demonstration of debugging an application with this setup. The information in this video assumes that you have the required products installed and licensed. These include Visual COBOL for Eclipse is required to debug a deployment image from the Eclipse IDE. This must be installed on a Linux platform. You can find information about installing and licensing Visual COBOL for Eclipse, as well as how to use many features of the product, in the YouTube playlist Visual COBOL for Eclipse in a Nutshell. Also required is a deployed image containing a COBOL application. A previous video, Deploying COBOL Applications for Docker in Eclipse, covers the process to create and deploy an image. The developer's Eclipse workspace must include a COBOL project containing the programs which will execute inside the container. One simple way to assure this is to use the same project that was used to create the image. Depending on the OS and version in use, the supported container solution may be Docker or Podman. The demonstration in this video uses Visual COBOL 7.0 Patch Update 2 with native COBOL on Red Hat Linux 8.4. On that platform, the supported container solution is Podman. The steps to debug remote containers running on Windows platforms are covered in a separate video in this series. To begin, let's look at an overview of the remote debugging process with containers. To allow the application to run within Docker or Podman, an image containing your COBOL application has previously been deployed onto another host and has an image name associated with it. By default, your application runs when a container is launched from the static image on disk. The image is configured to automatically invoke the application when the container is launched. We'd like to debug the application from Visual COBOL for Eclipse, which is installed on a development Linux host. To allow Eclipse to communicate with processes running inside the remote container, we'll first need to gather some information about the Podman environment, and then use that information to configure the runtime environment and Eclipse. Let's look at an outline of the required steps. First, we'll need to determine the IP address that Eclipse will connect to while debugging. This is the IP address of the Podman host. We'll also determine the ports that will be used when we connect. The first port will be the one for the Podman host itself. Since the container has its own network configured, we'll also need to know a port that will be running on the container. This can be the same port as used on the Podman host or a different port as shown here. With this information, let's remove the normal container launch from our conceptual picture and work through how we'll launch our container differently for debugging. When we launch our container this way, we'll use a different Podman run command with a special option to override the normal container startup. Instead of running our application, this will launch a remote debugging process inside the container. We'll see how to do this shortly, but here is an example of a command to launch the container this way. This is a single command, but I've split out certain options onto separate lines to better describe them. The first option, after Podman run, enables the capability for debugging inside a Linux container. The entry point option says to skip running the default executable. Instead, this option will launch a process for remote COBOL debugging. Since we'll be debugging a 64-bit application, we specify the version of the remote debugger named COB Debug Remote 64. The -P option specifies the ports that will be exposed to allow communication from outside the container. The first port specified is the port for the Podman host, followed by the port that will be used for the container. The next line tells Podman the name of the image to be launched. The last line shows parameters that are passed to the executable, which was specified above in the entry point option, COB Debug Remote 64. The first of these tells it to wait for connections on the container port we're using, 8080. The second option tells COB Debug Remote 64 that we want it to automatically place itself back into a waiting state after the debug session ends, ready for another debug request. When we execute this command, the container launches with the remote debugger running, waiting for debug requests. Returning to our outline, the last step is to start an X server to display any output from the running program, and then to create and launch a special Eclipse debug configuration with settings to connect remotely to Podman. In the debug configuration under Connection Properties, we'll specify the IP address of the host running Podman as the remote host. Under COB Debug Remote Port, we'll specify the port on the Podman host we've identified. Under Xserver Display, we'll specify the IP address and display number for the Xserver we started. In my case, I've started an Xserver on my Windows desktop. Finally, we need to specify the name of the main executable program for our COBOL application. Because it will be running inside the container, we'll specify the file spec for this file as it exists inside the container. When we launch the debug configuration, the Eclipse debugger will connect to the remote debugger process and launch the COBOL application under control of the debugger. Now, let's try the steps we've just covered. I'm logged into the remote Podman host, and I'll use the IPA command to determine the IP address. I'm planning to use the previously mentioned host and container ports, so I can proceed with launching the container. In a Linux command prompt, I'll use the Podman run command shown earlier to launch the remote debugging process. This will launch the debugger in an interactive command line session running inside the container. I'll make note of the name I gave my container. In this case, myremote_debug_container, as I can make use of this in the next step. When the remote debugger launches, it displays that it is waiting on the requested port inside the container. This command line session is now tied up with the remote debugging process. Now I'll launch a second command line session running inside the same container. I'll use a podman exec command to launch the second session, referencing the name of the running container and specifying bash to indicate that I want a Linux command line session started inside that container. This session positions me in the default directory for the container, which is where my COBOL application was deployed, /app. I can see the contents, including my COBOL executable, with an ls command. Now that the remote debugger is waiting, let's start the Eclipse debugger from the Linux development machine. I'm using the COBOL project that was originally used to develop the application, as it already contains the source for the deployed programs I want to debug. I'll right-click the project and choose Debug as Debug Configurations. There may already be some debug configurations for this project from when I debugged locally on the development machine. But it's a good idea to create a new debug configuration, specifically for remote debugging my application running inside a remote container. To do this, I'll select COBOL Application on the left and Create New. I'll give the new configuration a descriptive name Now I'll expand connection properties. In Remote Host, I'll fill in the IP address of the remote Podman host. I need to check the option to allow me to specify the port that Eclipse will connect to. This will be the host port we selected, which was 8000. Debugging a COBOL application running inside a Linux container requires that an X server is available. I have an X server running on my Windows desktop, so I'll provide the IP address of my desktop and the waiting display number. I'll uncheck the box Program as part of Project Build configuration for this case. I'll set the main program specification to reflect the name of the application executable as it exists inside the container. We saw earlier that the deployed executable was in the /app directory, so I'll enter that followed by the executable name. Finally, I'll click Debug. It may take a few moments for the application to start and the debugger to connect. And now I'm debugging the remotely running program. Over on the Podman host, I see that the remote debugger reports that it's connected. Now I can debug as I normally would. I'll step through the open output statement. I've placed a breakpoint in the program just after it has closed the report file in this program. I'll click Resume to let the program run at full speed. When I hit my breakpoint, I'll use my extra command prompt session to see the contents of the created file on disk inside the container. Now I'll let the debugger finish execution of the program. And over on the Podman host, I see that the remote debugger is now waiting again for a new connection. Since I'm done debugging, I'll enter a Q to terminate the remote debugger. Once the remote debugger we launched with the Podman run command terminates, the container automatically exits. Both command prompts are now showing the Podman host, and I can see that the container has exited. That completes this demonstration of debugging a COBOL application running inside a Podman container on Linux. Thanks for watching.